Hey everyone, in this video I'm going to go over the safe stack to build web applications, and as you can see here it says it's the best way to build functional first web applications, and I do believe that's true, and I'm going to go over some reasons in this video why I believe that's true. As you may have guessed, this is going to be using F# from not only this server but also using F# on the client side, and within it I'm going to show how you can use Mlf.net to make predictions in it as well. Now this video is my contribution to the F# Advent for 2020, and if you haven't heard of this, it's where people volunteer to write posts for a specific day of December, and when your day arrives, you publish your post. So each day there's a new F# post that comes out. It's a good way to kind of help get into F# and see what other people are writing about F#, and it happens every year, and it's like it's been happening for 10 years now, which is pretty cool. Alright, so we're going to get started here. Now, what exactly is the safe stack? So we read the docs here, and they actually have some really good documentation on the website. So, safe stack overview, and it stands for Saturn, Azure, Fable, and Elmish. Saturn is how you can build backend services in F#. Azure is the Microsoft hosting platform that I'm sure most of us are familiar with already. And Fable is for running F# in the browser, so we can write that client-side code within F#. And Elmish is kind of a paradigm for writing a model view update pattern in the client side, which is popularized by the Elm programming language. And feel free to go through each of these to find out more about them. Now, to get started in the command line here, the best way to get started is to just install and use the template that's out there already. And to install it, we'll do .NET new-i for install. It'll be safe, all capitalized, .template. There you go, so we got that installed. And I'm going to create a new directory. I'm going to call it safe. And I'm going to go into that directory, and then here I'll do .NET new safe, all capitalized, to use that template that was installed. -n to give it a name, and I'll just give it safe as the name. And if you look at what we have here, we got a bunch of files that the template installed. You may notice a couple of files that start with packet, and packet is a kind of an alternative to Nuget where you can use it to install your dependencies. We also have this build.fsx file, and that is using a tool called fake, which is similar to like make or cake or any of those other build command line tools, and we need to install those before we can continue. And to do that, we run .NET tool restore to restore the tools that we're using. So those got restored. Now we can kind of do a quick check to make sure that this runs okay. So .NET then fake tool build, and we'll set a target to run. So this is running that fake tool. We're invoking the build command, and we're running the run target. And then our target had run, it says install the client side stuff. So it's going to run npm here, and then before it does that, it did a clean. Alright, so all that ran successfully, and you'll notice up here, Fable compiled quite a few files that it had in there, and Fable will compile F# into JavaScript, which is why we can write F# on the client side. I kind of forgot to mention that when going over it. That's done, and you see it's still running. It's in watch mode right now. So if we go to our browser and go to localhost 8080, it's going to run that template. The template creates a kind of a small to-do app here, so we can add stuff. So record video, and it just adds it to the list here. Let's stop this, and we'll open this up into Visual Studio. Alright, so open the Solution Explorer. In the source, there's 3 different projects here. We have a project for the client side, one for the server, and then a shared project that hosts any shared types or anything like that. And then there's also a couple of test projects that you can go through. Alright, so in the server, I'm going to go ahead and start adding some ml.net stuff. So I'm going to add a new folder. I'm going to call it ml model. And the model I'm going to use is the salary model, where you get a predicted salary based off the number of years of experience. And it's a small model, but I just wanted to kind of highlight using ml.net instead of going mostly over how to use the model. There we go, so we got that model, and I'll link in the description a video where we actually built this model in F#. So I'm just going to make sure it copies during a build so we can have a reference to it. And there's two places I actually want to install the Nuget package. So first is going to be the server, because this is where we're going to be doing our predictions. So let's go to the Nuget packages here and install Microsoft.ml for ml.net. And this is using the new 1.5.4 package as of this recording. And then we also want to use it in our shared project here. And the reason we want to do that is that any types that we're using in our server we can put in our shared, so we can access this in the client if we need to as well. So Microsoft.ml, and we'll install that for our shared project. So get those installed. Let's go to our shared, and let's actually remove all this to-do stuff since we won't be using that. And we will open up Microsoft.ml.data. And let's go ahead and add our input and our output model types here. So we'll do type, and the first one's going to be salary input. That's going to be years experience. It's going to have a type float 32, and then salary, which will also be float 32. And for our salary prediction type as well, we'll use the ml.net attribute, the column name attribute. And this is going to be our score property that we will rename to predicted salary. And that's also going to be float 32. Now for this we need to put in the CLI mutable attribute on this type, since it's going to be, this is what ml.net is going to use exclusively. So it needs a CLI mutable type on it. I actually removed the route module here, so I paste this in. This just builds up the route, so the /API, then the type name, and then the method name for the API routing for our backend. We'll look at that a bit later. And then I want to create an interface type of salary prediction, and that is going to have a single method called get salary prediction. That's going to take in a float 32 for our years of experience, and that's going to return an async function, and it's going to return a string from that. Alright, so and that's all we have to do for our shared project here. Let's go to our server where most of the magic is going to be happening. And we got rid of all this to-do stuff, so let's just get rid of all of that. And real quick, this is where we also build out the web application itself using Saturn, where it uses that router here, and it uses the API to build the router. And then the actual app builds an application, gives it a URL, using the router, uses gzip, and we can add some other stuff in here too, such as we can enable cores, we can put in OAuth, so there's a bunch of other stuff that we can do there. So let's kind of build this up. So to use API, I'm going to use a prediction API, and let's define that. So let prediction API, and this is going to use this interface. So we're going to implement this get salary prediction method. So get salary prediction, and we're going to do a lambda here. So fun for function, years of experience is going to be our input parameter, and it's going to be an async function. So we wrap that into async, and then in our body here, we'll get a prediction. We're calling a prediction variable that predict salary method on that variable, passing the years of experience, and we'll do a match on this prediction with, and then with that prediction, when that predicted salary is greater than 0, I will return that predicted salary. I'll format that as currency. And for anything else, so when predicted salary is less than or equal to 0, I'm just going to return 0 as a string. So now we need this prediction variable. So we do let prediction equals a prediction type that we need to declare. And so let's do that up here. So type prediction. It doesn't take in anything as a constructor there. And this is where some of the ml.net magic is going to happen. So let's go ahead and create a context. So equals ml context. And we'll say open Microsoft.ml. Now we'll return the model through context.model.load from the ml model folder, salary model.zip. This load actually returns, if we hover over it, it returns a tuple, which is defined by the two types with an asterisk between the two. So the first item is the iTransformer, that's going to be the model. Then the second type is going to be the data view schema. If you remember in C#, the data view schema is an out parameter, so that's why we have a tuple in F#. So just write that in parentheses to denote that it's a tuple, and we're going to unpack that tuple. So we get the first item, which is going to be the model, and then the last item, which would be the data view schema, and because we don't need that, we'll just do an underscore to kind of ignore that value. Next, we create a prediction engine using context, model, create prediction engine, and this is where we're going to use that shared. So we use a salary input and salary prediction types there, and pass in the model. And now because this prediction has a predict salary method on it, so we'll implement that with member, do double underscore dot, and then our predict salary, which is the name of the method. Years of experience will be the parameter to it, and then let predicted salary, so we use the prediction engine, that predict, and we'll pass in a type here. So we'll bring in years of experience as years of experience, pass that in, then we'll just set salary to 0, and then return the predicted salary. Alright, so that's all we need to do for the server side. So now let's go to the client side in the index.fs class, and we have some errors here because we're still referencing some of the to-do stuff. So the first thing, let's update this model type. Now the model type is going to be the state of our client side information, and so for the to-do application we have this to-dos, which is just the current list of the to-dos, and then the input, which is going to be the input from our text box. So we're going to keep the input because we still need that to gather our years of experience, but we're going to change this to-dos, say predicted salary, and this is going to be a string. Next we have a message, and this represents the different events that our application can send to update the state of our application. So for instance, when we set the input, that's what event gets handled for setting this input in the model. So once again, we're going to keep that, but let's get rid of the to-do items, and we're going to put two more here. First is going to be predict salary, and then next we're going to do predicted salary. That's going to be of a string, because we're going to get a string back here. Predict salary, we're not going to get anything back, it's just something to let us know to send to that prediction API. API here, we'll rename this to prediction API, and we'll just set this to salary prediction. In the init, our default model input is blank, and we'll set predicted salary to an empty string as well. Change to-dos API, and we don't need to get our to-dos or anything else when we first instantiate this, so we'll just remove this. And because we need a command here, we'll say command.none. In our update, this is how we handle these events that get set from our messages. So we remove the to-dos, going to keep that set input in there. So we add one, and real quick, if I hover over this message, we actually get this warning that we have incomplete pattern matches. So that's another cool thing about F# is that the compiler generally helps you out. Alright, so for predict salary, what that's going to do is I'm going to get the actual salary from the model.input, but that's still a string, so if we hover over it, it's still a string there. So what we can do is we can call the float32 method on it to parse that out into a float32, and then we can take that and build a command. So command of async.perform, and we use that prediction API that gets salary prediction, pass in the salary, and then we update our model with input. We blank out the input because we just used it, and then we pass in our command. So our model is right here, then our command of message is there. Oh, and we also need to pass in what other command to perform after this gets called. So that would be the predicted salary. That takes the input and parses it out to a float, and it calls the get salary from that, and then it instantiates this predicted salary message, which we can implement here, predicted salary, and then we get a new salary from that. And all this does is that it updates the model with predicted salary as the new salary, and then we don't have a command, so we do command.none. So that handles all of the messages that we have. So next, let's update the actual HTML for the UI part. You may have already noticed that there is no HTML in the client side here. We do have the index.html, but that is similar to React. It's just going to bind on this div, and then we build out everything else in F#. And this is using a package called Forma, which is an F# implementation of Bulma. And Fable is using React behind the scenes, so we're pretty much writing on JSX here within F#. Now the first thing is we don't have an ordered list of to-dos anymore, so let's remove that. And instead, we want a div. And the first brackets here indicate what classes we want on this div, and then the second set of brackets what contains inside the div. So within the div, we want a label, and inside that label, we'll do an if statement here. So if not system.string is null or white space, the model predicted salary. So if the predicted salary is not empty or null, then we print predicted salary, give it a placeholder, and then we use that model.predicted salary. We have an error that it's a React element and not a string, so we can pipe all of this into the str method for a string to alias of string, and there we go. That gets rid of that compile error. And so if this is false, then it's not going to print anything on in the UI. I'll update this placeholder. I'll say how many years of experience, and on change it's going to set that input. It's going to call it a dispatch to set the input based on that value. And down here in the button, we don't need a disabled check there, so I'll remove that. When we click on the button, I'll dispatch the predict salary message. For the button string, I'll call it predict. Alright, so that should be all that we need to do on our client side. Let's go back to our command line, run this again, make sure it builds and runs correctly that we expect it to. Alright, so our run target ran, and there's no errors or anything. So we can go back to our localhost here, we'll refresh. So we get our updates here, so our placeholder updated and all that. So now let's put 8 years of experience. There we go. We got a predicted salary, $97,500. So we were able to implement ML.NET within our SafeStack web application here. Now real quick before we finish the video, there's one thing I do want to show here. So debug on the client side here. You may expect to see JavaScript here, but we actually see the F# code that we actually wrote. So when we debug on the client side, you're debugging in F# and not in compiled JavaScript. Put a breakpoint in our predict salary message. So we'll do 5 this time. Predict. So we have a model input 5. Continue there. We have an updated salary of 68,000. In the SafeStack documentations show how you can debug the app here. For Visual Studio, we just got to configure the launch settings. So in our properties /debug in Visual Studio, so properties on the server launch settings, we just have to make sure this matches what we have here. So it's like the main thing we need to do is to set this launch URL, make sure that is set correctly. So there's application URL and launch URL. So we add that, and the same thing in the server side. So now let's set the server as startup project, and let's run that. And while that's compiling, I'm gonna stop the fake target from running. So our server is running, but we still can't reach the page, and that's because we need to start the client. So when you go to the source/client and then run npm start in there, Alright, so npm start ran successfully. Let's go back here and refresh. There we go, now we're able to run. So let's put a breakpoint somewhere in our server. Predict salary method. So we'll do 8 again. Alright, so sorry for the cut. I was actually getting a gateway timeout when doing this on the server. So what I had to do was I had to double check the launch settings and match what we had here. Mainly the application URL up here and then down here, and I had to change the SSL port to make sure that matched. So now put in our years of experience, say 8. Now we get breakpoint in our server side, so we can debug in here. Years of experience is 8. Keep going. Now we have a predicted salary, and we can continue, and our predicted salary comes up there. Alright, so I hope this showed you how easy and nice it is to work with the safe stack, especially in F#, and using ml.net with it. Hope you enjoyed the video, and thanks for watching.